shall talk about something called as attribute construction. Here, what did we do? We have taken a specific column which was in categorical format. We applied our common sense or domain knowledge, and then we converted that into some numbers. High school means minimum 12 years of education. Bachelor's means 14 years of education. These are a few values which are well known. So you're just converting the categorical data into numeric data by applying attribute construction. This is one way to look at it. Or feature construction. Another way to look at it is looking at the original dataset or the dataset which is provided to you by the customer. By looking at that, we trying to do something meaningful. We have built a specific prediction model for a customer, for a truck manufacturer. Okay, and just to give you all a sense, if you go to Project Management Institute, Survival Analytics, okay, you would see the first paper, which is Bharani Kumar paper. Even if you look at, this was way back in 2017. Yeah, yes. Back then, when Mr. Nambi Narayanan was speaking, a lot of people didn't knew. But after the movie Rocketry, a lot of people know about Mr. Nambi Narayanan, right? Anyways, back then he was there, Vishwanathan Anand was there, etc. Now in this, there was awards section. Not sure whether I can pick that. Nambi Narayanan was there. And there were 4 themes, friends. In all the 4 themes, people have presented the projects from across India. All the high-profile projects, even people from Deloitte. I have worked with Deloitte, so they have also come presented the project that they have completed. And then we have also done that. And we were there in a rapidly changing world. And that's me, right? Survival analytics. And you know what? Until last moment, we weren't called. Everyone was getting first position, second position, third position. First, second, third. First, second, third. First, second, third. We weren't called. We were like, oh my God. We felt our project was so very different and no one has called us. And you know what? They called us towards the end and they told that out of all these 4 tracks, there was one project which was the best, and that happens to be your project. And that was a winning moment. I think that we should. The other people were saying, hey, let's go. I think we didn't win it. I told, no, we will win it. That's me. Back then, probably I was a little fat, but then, yeah. Okay, anyways. And why am I talking about that? Because this is related to that. Yes. So, it was all about vehicle breakdown prediction model. We are in 2022. I'm talking about 2017 when we have accomplished this project. So we connected a lot of IoT devices to the truck, and then we started getting important data. And then we use that data to predict whether a vehicle is going to break down or not. And we had a lot of variables that we have chosen. I would speak about a few variables which probably would make sense. We wanted to predict whether a vehicle will break down or not. That was the output variable. Will a truck fail or not fail in a specific journey? if you're transporting goods from one point to another, would that specific truck break down or not? And we had a lot of inputs. One of those inputs was date of manufacture. Date of manufacture. Then we also had date of failure. Date of failure. On which date did the vehicle actually fail? Date of manufacture was the manufacturing date, and then we had date of failure. And then we had number of kilometers driven. We had the engine coolant level. And then we had other columns such as latitude. And we also had longitude. If I were to ask you this question on use your domain knowledge, if I say this, use your domain knowledge and tell me which of these variables do you want to use for building your prediction model? According to your domain knowledge, do you think all these inputs are equally important to predict your output? Yes or a no? So if you feel that a few of these are not important, what would those be? Right? I'm sure a few of y'all might be thinking that, hey, do you know what? A few columns I feel are irrelevant. A few maybe can be thrown away. Only a few can be kept, right? But then raw data is your number one enemy. I've already made this statement at the start of this phase called data pre-processing. The raw data that comes to you, you need to attack that. If you look at date of manufacturing and date of failure, using these two columns, say the vehicle was manufactured in 2018 December, and the failure happened in September 2022. If I were to subtract these two, without using these as is in my prediction model, if I were to, reduce these two into one, that would be the age of the vehicle. Okay, it would be the age of the vehicle. And if you look at the age of the vehicle, you know for a fact that that would turn out to be what? Maybe 21 months, 21 months. So rather than use these two columns, you can use a single column now, which is called as age. Then you have number of kilometers driven. You have the engine coolant level, whether the coolant level is low or high. If the engine coolant level is low, your engine gets heated beyond a point, it might crash. And you have two other columns, which are latitude and longitude. We can use latitude and longitude and come up with a new column called as altitude. Or maybe I can come up with a new column called as location. Based on the location, you can figure out whether that is a desert or is that a hilly terrain. Right? You will be able to figure out. So you need not throw away these two columns assuming they are meaningless, but then from these two, you can come up with a new column called location, and this would be more meaningful for analysis. Okay, then if you look at date of failure, if I were to take only this specific column, you can understand from the month whether it is a summer season, winter season, rainy season, so on and so forth. Summer season, desert, chances are very high that your vehicle might fail. Probably there is a pattern that you are learning. But rather than using your raw data, if you were to use your data in this fashion, it makes more sense. Right? It actually makes more sense, actually. So from date of manufacturing to date of failure, you're coming up with a new column called age. By using latitude and longitude, you're trying to come up with a new column called location. And instead of date of failure, you're using different seasons. From the months, you can deduce the season. And now it becomes meaningful to use this new data in your analysis. In that way, say you have Google AdWords. When it comes to Google AdWords, you would certainly be interested in clicks, number of clicks, which could be one of the columns. But then if an ad is appearing and then if someone is clicking on that, is that more important for you? Or suppose there are two columns, right? Number of impressions. Okay, and then you have, say, another column called number of clicks. Then you have number of purchases. On some e-commerce portals, say people are purchasing products. But then assume that e-commerce portal is doing some advertisement. Okay. And while that e-commerce company is doing advertisement, it would that specific ad would show up. Each time that ad shows up, that's called as an impression. Say the ad appeared 1,000 times. Out of 1,000 times, how many people have actually clicked on the ad can be obtained by dividing number of clicks by number of impressions, and that is called as click-through rate. Number of times people are clicking out of number of times that ad appeared. This is click-through rate. And then, how many people are actually purchasing the products? Not just click. You click and then you need to purchase, right? So using these two, probably you can come up with something called as throughput rate. That is number of purchases divided by number of clicks. This would give you throughput rate. Rather than using the raw data as is, if you can compress this into two different columns, probably the analysis would be more meaningful. So this is called as attribute construction or feature construction, wherein you're using your existing features or attributes and you're trying to come up with new attributes or new features. Let's take yet another example of credit card. Suppose you want to figure out whether a specific credit card transaction would be fraud or not fraud. And assume that customer the bank has given you data such as place of previous transaction. Say the second input was time of previous transaction. Say you have another input, which is place of current transaction. Say you have another input, which is time of current transaction. If you have 4 columns, and if you want to predict whether a credit card transaction would be fraudulent or not, then you can use all these 4 inputs as is for your analysis and then predict a model. You can supply the data as is to your machine learning algorithm, but that would make your analysis complicated, isn't it? I would just tell you what happens if you build a regression algorithm on this. There will be a lot of machine learning algorithms, and regression analysis is one another algorithm. We would talk about this algorithm at a later point of time frame. Don't worry until and unless I explain that concept, but please remember this term which I used, regression, right? So that's good enough. When you use this data as is and build a model, you'd get a model like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. Okay, and using these 4 inputs, can I come up with new inputs? Certainly yes. How would you do that? If I were to look at time of previous transaction and time of current transaction, using these two, say the previous transaction happened at 8 p.m. and the current transaction happened at 9 p.m. So the difference is 60 minutes. So you can come up with a new variable called as time lag, time difference. Not just that, you can use these 2 variables, which is place of previous transaction and current transaction, and find out the distance between these 2. One might happen in New York. Maybe another transaction happened in Kuala Lumpur, Malaysia. What is the distance between these 2 locations? If you subtract, you get the distance. So within 60 minutes time, a transaction is happening as far apart as New Jersey or New York versus Kuala Lumpur. There's a huge difference. How can 2 transactions happen within 60 minutes in such far up locations? So the moment you have these 2 columns now, which is time and distance, your analysis would be better. And your algorithm, which was such a lengthy equation, has condensed significantly. Now, using these 2 inputs, if you build your model, you get beta naught plus beta 1 x1 plus beta 2 x2. So beta 1 into time lag plus beta 2 into distance. Now, using these 2 inputs, can I come up with a new variable altogether, further making the model simpler? Yes, why not? Physics should come into picture now. And you know what? We have a formula called velocity. Velocity is distance upon time. Distance divided by time would give you velocity. And this becomes your new variable now, speed or velocity. And if you have this single variable, you can predict whether your credit card transaction is fraud or not, and your model equation would become extremely simple. And there is an English statement, which is Occam's razor. Or principle of parsimony. According to principle of parsimony or Occam's razor, simplest of the models are the best models that you can ever build. Simplest of the models are the best models. So the first preference probably should be given to this. The next best would be this, wherein you have only two inputs, and yet you are able to accomplish your output. And the worst would be, or the least preferred, I would say, would be using your raw data as is and building your model. That is not preferred. So you need to apply your domain knowledge and get the things moving. Then we have something called as body mass index, wherein you take weight and height, both of these variables. You combine those two to come up with a new variable called body mass index. And you can use body mass index for further analysis, as opposed to using the raw data wherein you have the height and the weight of a person. This is attribute construction. Always attack your raw data. Don't let your raw data be as is. Attack that and solve it. Okay. So this is about attribute construction. So the moment you have the data set to deal with, don't proceed further with that. Analyze in this manner, and only then can you proceed, or should you proceed further. I'll give you another dimension here to this attribute construction. And post this, we'll get into our imputation techniques. Suppose there are three banks: HSBC Bank, Standard Chartered Bank, and say you have State Bank of India. This is the bank with which I've worked. That was the first company with which I've worked. And we have our banking relation with Standard Chartered and State Bank of India. We have actually done a project for them. Okay. So in the data set, suppose you have two columns, which is income and debt. And say you want to predict whether a person will default on the loan or not default. You have income and debt details. If you have these two inputs, only income doesn't make sense. You might be getting $1 million, but if your debt is also $1 million, then you would be a bad customer for me. You might default on the loan, right? So just one column doesn't make any sense. Just debt or just income would not make any sense. Say the people in HSBC use the raw data and built a model. Say they built a model like this: beta naught plus beta 1 x1 plus beta 2 x2. This is project from HSBC. Then, if you take these two columns and say income upon debt, if you do that, you get a ratio, income to debt ratio. So by doing that, you are able to reduce the two columns to a single column. So you're ultimately ending up building a simpler model. And what does Occam's razor or principle of parsimony say? Simplest of the model is the best model. But then say people working in State Bank of India are very intelligent folks. what would they do? They would probably take income and they'll try to plot income and the population or all the customers that they have. So if you plot your customers on x-axis and if you plot income on y-axis, probably you will see a curve like that. What does that mean? Is this a linear curve? No. And just remember your COVID-19 cases. They were exponentially increasing. They slowly increase, but after a certain point, they start exploding beyond a point, like a bamboo. This means that huge proportion of customers would either belong to low income group or middle income group. Only a small proportion of people will belong to high income group. Only a small proportion of people will be probably Mark Zuckerberg, Elon Musk, etc., right? This is how the world is. And the economists would 100% agree with this, that income follows what kind of a distribution? Exponential distribution. And you might want to check with any economist. They would say that, hey, debt also follows exponential distribution. If you look at debt, and if you look at your customers, and if you were to plot it, this is how it would be. Majority of them would have less debt. Only a small proportion of people will take huge debt. Industrialists, maybe. This would also follow exponential distribution. Whenever you have exponential distribution, that distribution would be captured using a log. So you should not end at income by debt ratio. Instead, the nice variable would be log of income divided by log of debt. Okay, so you do a log of income by log of debt, and that would give you the input. So your output variable now would become beta naught plus beta 1 x, and this x is nothing but this new variable. So should you take your raw data and build it? Sure you can, but the accuracy would not be great. And also you're using all of your inputs, so your model will become complicated. As in how you keep adding new and new columns, you're making your model more and more complicated. If you perform feature engineering and come up with new features, that is if you do feature construction or attribute construction, using your columns, you're trying to come up with a new column altogether. Say income over debt. And if you apply your brain further, you would say, let me take a log of income by log of debt, and that is this. Right. Wherein your input is log of income by log of debt. And this model would be most appropriate and would give you amazing results. So this is feature construction for us.